This video is a mixture of section 11.2 on permutations and section 11.3 on combinations. Before we get into those formulas, we first have to be familiar with some notation. Specifically, we have to know what this exclamation point means in probability and statistics. We read it out loud as a factorial. Factorial. So keeping that in mind, let's jump into example 1. It says to evaluate the following factorial expressions. Starting with A, 4 factorial. So whenever you see this factorial or this exclamation point, you're going to start at the number that comes right before it, which is obviously a 4 in part A. And what that factorial means to do is to multiply that number by every single number below it, all the counting numbers, down to 1. So 4 factorial really means 4 times 3 times 2 times 1. And when we multiply out 4 times 3 times 2 times 1, we see that really 4 factorial equals 24. So 24 would be the final answer for A. Inside the word factorial, we see factor, which reminds us of algebra. And whenever you factored in an algebra course, really you were rewriting something in a multiplication format. And that's really what we did with the factorial as well. We rewrote the number in front of the factorial symbol as multiplication, but in this case, it's down to 1. We could also make the graphing calculator do it, and you're going to want access to a graphing calculator for this entire chapter anyway, especially by the end of this video. It's going to save you a lot of time. If you do not already own a graphing calculator, keep in mind you're welcome to download the app onto your phone. And then on test days, you can check out a graphing calculator from any library or mathematics tutoring center at Valencia College. The app, if you have not already downloaded it, for Androids, it's free, so why not try it? It's called Wabbit Emu, all one word. Once you download it, it'll give you a list of Texas Instrument or TIs to choose from. Any TI 84, Texas Instrument 84, would work great. So you can pick any of those from the list after you download it. For iPhones, it is not free, sadly. It keeps fluctuating in price. The last time I checked, it was $5.99. I have seen it as low as 99 cents, though, some semesters. It's also just one word. It's spelled graph with an F, so graph is actually misspelled. Graph, capital N, calc 83. Graph and calc 83, no spaces. Both of these apps are awesome. They look exactly like the actual graphing calculator. The buttons are on all the same exact spots. So you'll definitely want to download the app for your phone if you do not already own a graphing calculator. That way, at the very least, you can do the My Math Lab homework and the My Math Lab quizzes using those buttons that I'm going to show you throughout this video and in the future videos for this chapter. Okay, so bringing up my calculator onto the screen so I can show you where the factorial button is located at. So you would type in the number first, so I type in the 4 first, and then our favorite button for chapter 11, we're going to use it a ton, is going to be the math button. So it's the third button down on the left side. It's right below the colorful alpha button. Your alpha might be a different color than mine, that's fine. But hit the math button. As soon as you hit the math button, you want to use your arrows to scroll over to PRB. It stands for probability, the probability submenu. Both the counting and some of the probability formulas are located under PRB. It's actually quicker to get there by using the left arrow key, because if I hit the left arrow key, it's only one button click. And then as I look at the options, I see the exclamation point, the factorial, is option 4. You can either hit the down arrow until it's highlighted and hit enter, or I think it's easier just to simply select the number that's beside it. Heads up, we will be using later in this video the NPR and NCR features as well. So for now though, I'm going to hit 4 for factorial, comes onto the main screen, and then I hit enter on the bottom right corner for equals, and bam, there it is, 24, final answer. So again, type in the number first, then math button, left arrow to PRB, option 4, enter. So either way you do it, longhand or calculator way, you do get 24, final answer. Looking at B. B wants us to now do 8 factorial. 8 factorial. So what does that mean? It means to start at the number before the exclamation point, which is of course 8, and to always multiply every counting number below that down to 1. So that would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, when you get a bigger number, it's much more time consuming, as you can see, to do this longhand, which is why you would probably want to just type this into the graphing calculator. When you multiply all those numbers out, you do get 40,320 as your final answer. So I type in the 8 first, math button, go over to PRB, option 4, enter, and I see it's 40,320 as the final answer. Looking at C, C wants us to find 0 factorial. It's one of those oddball rules in math. Surprisingly, 0 factorial will always equal 1 as the final answer. You could even just type it into the graphing calculator and you would also get a final answer of 1. From here on out, just know 0 factorial equals 1. For the proof of this, you can check your ebook, which you can access through my math lab. They explain it, they go into better detail. Looking at D, they also want us to divide factorials. So D says to do 26 factorial divided by, so they're going to probably use a fraction bar for division, same thing, divided by 21 factorial. It's good to know how to do this longhand because for some of these types of questions, the graphing calculator is not going to cooperate. To do this longhand, we have to know what factorial means. So if I rewrite the 26 factorial that's on the top, that means 26 times 25 times 24 times 23 times 22 times 21 all the way down to 1. You would multiply all the way down to 1. Whereas the 21 factorial on the bottom means to start at 21 and multiply by every number below that down to 1. And as long as you're only multiplying, you're not adding and you're not subtracting on the top and bottom of a fraction, you are allowed to cancel out the matches to simplify the top and the bottom. So wherever the top and bottom match, they match at 21 on down to 1. So 21 on down to 1, we can slash, and really the only thing left to calculate is 26 times 25 times 24 times 23 times 22. So that's how we would do this longhand without the graphing calculator. The final answer is going to be a large one. It's going to be 7,893,600. Now let me show you the same exact question if you did want to just type it into the graphing calculator. Please be aware that it has to be typed in as one line to get the answer in the graphing calculator. Typing it in, so we had 26 factorial, so math button, left arrow to PRB, option 4, fraction bar just means divide, so I hit the division button, 21, math, PRB, option 4 again, enter for equals. So this is one where the calculator does cooperate, and we see the final answer is 7,893,600. If you tried to break this up into two parts, so let's say you just did 26 factorial first, and then tried to, in step 2, so you hit enter, in other words, too quickly. So if you hit enter right after 26 factorial, see how you get E, which is scientific notation? It's such a large answer, the calculator is not going to cooperate with you. Again, the calculator can only hold so many digits. So that's why you have to do this as one line to get the answer in the calculator. E wants us to do 500 factorial divided by 499 factorial. Now this is one where the graphing calculator is not going to cooperate, just because when it first does 500 factorial in the numerator there, it's such a large number that your graphing calculator cannot hold all those digits. So let me just show you what that looks like when you try to do it in the graphing calculator first. When I punch it in, we got 500, math button, go over to PRB, option 4, divided by for fraction bar, 499, math button again, PRB, 4 for factorial, enter for equals. See, this is error overflow, meaning there are just so many digits, the graphing calculator does not hold all those digits for the numerator and denominator, because it would do the 500 factorial on the top calculation first, and it can't hold all those digits of that huge answer. So we're going to have to do this question longhand to get the right answer, is what that means. So writing this out longhand, remember we have 500 factorial divided by, so they would write it as a fraction bar in the My Math Lab. The division is just fraction bar. Divided by 499 factorial. So we have to summarize what factorial means. So 500 factorial means 500 times every number below it down to 1 times 499 all the way down to 1. On the bottom, 499 means to multiply that by every number below it, also down to 1. Then we cancel the matches on the top and bottom, which is 499 all the way down to 1. And what's cool about this question is the only number left in the numerator is 500, so that must be the final answer. So 500, final answer. Example 2 says an order of award presentations has been devised for 7 people: Jeff, Karen, Lyle, Maria, Norm, Olivia, and Paul. Part A, in how many ways can the people be presented? So thinking back to the last video on section 11.1, we said when in doubt, when you're counting, you're going to multiply, and that's what we're going to do here. There are two different ways you can tackle a counting question whenever you're rearranging all the people or all the items in a line. So whenever all the items or people, whatever the word problem is talking about when it says in how many, and you're rearranging all those things in a line. The first option is you could tackle it like we did in the last chapter where I was drawing underlines. So in this case, since there are 7 people lining up for this award presentation, I could draw 7 underlines. So 1, 2, 3, 4, 5, 6, 7. We're going to multiply because it's still the counting principle. And then we put the total number of options with each underline yet again. So going left to right, there are 7 total people that could potentially take the first spot in line for this award presentation. One of those 7 will end up going with the first spot, and then you're down to 6 people. So if it helps, let's think of an example. So let's say you have 7 people, and I'm going to pretend Jeff goes in the first spot. Then we're down to 6 people: Karen, Lyle, Maria, Norm, Olivia, and Paul. So I'm going to say Karen is the one that gets the second spot. Then you're down to Lyle, Maria, Norm, Olivia, and Paul. So you're down to 5 choices of people that could pick the third spot. One of those 5 will end up getting that third spot. Let's pretend it's Lyle. Then you're down to 1, 2, 3, 4 people. One of the 4, I'll say Maria gets that spot. You're down to 3. I'll pretend Norm got that spot. Then you're down to 2, Olivia and Paul. I'll say Olivia got that spot. And then you're down to Paul. So you're down to 1. So you end up with 7 times 6 times 5 times 4 times 3 times 2 times 1. That's the long way of doing it. So you could treat it just like we were treating the other counting principle questions in the last video. Or whenever it says how many, so it's a counting question and you're rearranging all the items or all the people in a row, the quicker way is to use a factorial like we were doing on the last slide. And you can even see 7 times 6 times 5 times 4 times 3 times 2 times 1 really is summarizing 7 factorial, because we started with 7 and we multiplied it by all the numbers below it down to 1. So the formula that you could use for this is you take the total number of items that you're rearranging in the line and you subtract from it the number of restrictions. And that's going to go in parentheses, and then you put a factorial after that. So total number of items you're rearranging minus the number of restrictions, close the parentheses, factorial. What do I mean by that? Well, in the context of this question, a restriction would be like if Olivia has to go first, or Maria has to be in the middle, or Karen has to go last. That's what I mean by restrictions. So in question A, if I wanted to use this formula, the total number of people being lined up were 7, minus there were 0 restrictions in A. Factorial. So 7 minus 0 is, of course, 7. So you do parentheses first, and then we still get 7 factorial. Now you still have to punch that into a calculator. You can't just leave your answer as 7 factorial. So let's go ahead and put that into the graphing calculator. Punching this into the calculator, we had 7, math, go over to PRB, factorial, option 4, enter, and we see the final answer is 5,040. So 5,040 is what you would actually type into the My Math Lab answer box. 5,040. Okay, taking a look at B, it says, in how many ways can the first award be presented to Karen and the last to Lyle? So again, you have two options. It's up to you how you want to get the right answer. You could draw the underlines and multiply the total options. I'm going to do it the quicker way, which is using our formula, where we said we take the total number of people that we're rearranging in a row or in a line, and we minus the number of restrictions. And we do that first, that's in parentheses, and then we tag a factorial, so that exclamation point symbol after the parentheses. So in this case, the total number of people is still 7, minus, well, the restrictions were that the first award has to go to Karen and the last award has to go to Lyle. So there are two restrictions, first to Karen and last to Lyle. Close the parentheses, factorial. We always do inside parentheses first. So I'm going to do the 7 minus 2 for 5 factorial. Then 5 factorial, you want to put it into the calculator. When you do that, please check on your own graphing calculator, but you should be getting 120 as the final answer for B. Finally, C, in how many ways can the third award be presented to Paul? So using the formula, because again, we're talking about rearranging all these people in a row, in a line. So I can use this factorial formula, I'll call it. But the total number of people is still 7 minus the number of restrictions. There's one restriction here. The third award has to go to Paul. Factorial. So I do the 7 minus 1 first, which is 6 factorial. Now you'll want to punch that into the graphing calculator. So 6, math button, PRB, option 4. And if you've done it correctly, you should be getting 720 as the final answer for C. So whenever you're rearranging, you're counting how many, and you're rearranging all the items in a row, whether it be horizontal row or vertical row, you can use this factorial formula to get the right answer. The next formula deals with if you're counting still, but if there are duplicates or repeating items. So you're still going to rearrange all the items, whether it be in a row, in a straight line, or a vertical line, but we want to be on the lookout for anything that repeats, because when it repeats, we have to divide away whatever repeats so that we don't double count it. So we call this formula the permutations of duplicate items. And the official formula, it's not as bad as it looks, but here's the official formula from your ebook. The number of permutations of n items where p items are identical, q items are identical, r items are identical, and so on is given by this formula right here. And as you look at this formula, there are a lot of factorials. There are a lot of exclamation points. So we're still going to be needing the graphing calculator to punch in this formula. But pretty much it's going to be the total number of items, factorial on the top. That's what that n factorial on the top of the fraction stands for, divided by parentheses and whatever repeats, the number of times it occurs, factorial, and everything gets a factorial. You do need parentheses around the denominator. If you forget them and you have several items that repeat, you're going to get the wrong answer in the calculator. So even though my Math Lab View an Example does not show these parentheses, you do need to type them in when you're punching this in as one line into the graphing calculator. Once we see an example of this formula in action, it's really not so bad. So taking a look at example 3, it says in how many, so we're still counting, we still see the phrase how many. In how many different ways can the letters of the word Tallahassee be arranged? So we're going to rearrange all the letters of Tallahassee, and because Tallahassee has some letters that repeat, the A, there are several A's, the S's, the L's, the E's, because I see some letters repeating, that's why we don't want to double count anything, so hence the fraction bar in the formula. We're dividing away whatever repeats. So before I use the formula, I like to just write out the layout off to the side. So in Tallahassee, let's first count how many total letters there are. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 total letters in Tallahassee. Then let's count how many of each letter there is. So we have 1 T, and I'm going to slash as I go just to make sure I don't forget any letters. So there's 1 T. There are 3 A's. 1, 2, 3. There are 2 L's. There is 1 H. There are 2 S's. And there are 2 E's. There we go. Now that we have the layout, let's go ahead and plug into the formula. We said for the formula, you're going to take the total number of items and put it on the top of the fraction with a factorial. So there are 11 total letters. So I'm going to write 11 factorial on the top of my fraction bar. Don't forget the parentheses now on the bottom. And all we care about is what repeats, so whatever we have 2 or more of. So I see we have 3 A's, so I'm going to write a 3 factorial to represent the 3 A's. It goes on the bottom of the fraction. So again, anything that repeats, put it on the bottom of the fraction bar here. Check, we have 2 L's, so times 2 factorial also goes on the bottom to represent the L's. Check. We have 2 E's, so I write a 2 factorial to represent, there are 2 S's rather. So I write a 2 factorial to represent the 2 S's, but there were also 2 E's, so I'm going to write another 2 factorial to represent the 2 E's. So however many of the item there is, when it repeats, that's what you throw on the bottom of the fraction, and it all gets its own factorial. Now, you might be going, but what about the 1 T or the 1 H? Because the T's and H's did not repeat, you don't have to write 1 factorial. You can if you want to. It's not going to hurt anything. You're going to get the same exact answer. So I do see some people sometimes that'll do like 1 factorial to represent the 1 T, and they'll do another 1 factorial to represent the 1 H. But 1 factorial just equals 1. And if you multiply a bunch of numbers by 1, you're going to get the same number back again. So really, it's just more work that you don't need. So that's why I only focus on what you have 2 or more of, what actually repeats. And that's what I would recommend throwing in the bottom, the denominator here. So now we're ready to go. We just got to punch it into the graphing calculator. So putting this all as one line into the calculator, first we had 11 factorial. So I type in 11. For every time we need a factorial, that's that exclamation point, we have to hit the math button. Third one down on the left side. So math. Now I go over to PRB submenu with the left arrow. It's going to get me there quicker. Number 4 is the factorial. Fraction bar just means division, so I hit the divided by button. Parentheses are above the 8 and the 9 keys, so I hit parenthesis. Then we had a 3 factorial, so 3 math, PRB, factorial, times, and you can just mush all these factorials together. In the denominator, the calculator is going to know that that means to multiply them. So 2 math PRB factorial, and then we had another 2 math PRB factorial, and we had a third 2 factorial. I wish there was a copy and paste. It'd be so much easier, but unfortunately there's not. So I have to keep hitting the math button, go over to PRB, option 4 every time I want a factorial, close those parentheses, hit enter on the bottom right corner for equals, and final answer, 831,600. 831,600. Now, this is what happens so many times on the test and why people get this wrong. If I bring up the same line, if I hit second enter, which is entry, so second enter, I can bring up the previous line on my graphing calculator. And let's say that you forgot those parentheses, which is easy to do since my Math Lab View and Example does not show you those parentheses, but they are needed. So I'm going to delete DEL, those parentheses, and I'm going to delete this left parenthesis as well. And now I hit enter and see how it's a totally different answer. It's the wrong answer. So please, please, please write a reminder in your notes. You do need parentheses around the denominator of this formula, even though my Math Lab does not show you those parentheses. So the correct answer was 831,600. 831,600. Let's try another one. It might not always be repeating letters in a word. There's a flag example I've seen in the My Math Lab homework as well. So example 4, there are 10 flags, 3 red, 2 blue, 2 purple, 1 yellow, and 2 green. In how many different ways can the flags be arranged in a line? So even though you're rearranging all the items in a line, it's not just the 1 factorial formula from the previous slide, because some of the colors repeat. We got duplicate colors. So that's our cue to use this duplicate items formula where we have factorials all over the place. Just like with the last example, I'm going to write the game plan off to the side first. So there were 10 total flags. We had 3 red, we had 2 blue, 2 purple, we had 1 yellow, let's put 1 Y for yellow, and we had 2 green. So the total number of items you're rearranging goes on the top of the fraction bar. There were 10 total, and it gets a factorial divided by parentheses around the bottom. Everything that there is 2 or more of. So there were 3 red, so 3 factorial to represent the 3 red, 2 factorial to represent the 2 blue, times 2 factorial to represent the 2 purple, and another 2 factorial to represent the 2 green. It's up to you if you want to put a 1 factorial to represent the 1 yellow or not. You don't need it since the yellow does not repeat. So this whole thing is what you're going to type into the graphing calculator, parentheses and all. So try it. After you type it into the graphing calculator, just to check your answer, you should be getting 75,600. 75,600 as the final answer. The next 2 formulas are more counting formulas. However, instead of counting out and rearranging all the items, we know we're going to use one of these 2 formulas if the question says you're only going to pick out a handful, a subset, a small group of the whole, and rearrange and count out just that subset. So just a few you're selecting out of the whole group. So as soon as you read these word problems and you see, okay, I'm only picking out just a handful of items and rearranging it, you've already narrowed it down to it's either the permutation formula or the combination formula when that happens. So the permutation formula says the number of permutations possible if R items are taken from N items is, and as we look at that formula, we see lots of factorials. We got an N factorial on the top divided by parentheses n minus r, close the parentheses, factorial on the bottom. However, you don't have to use this formula because there is a button, yay, on the graphing calculator where this formula is already programmed in there, ready to go. So I'm going to use the graphing calculator. Please note that the N and the R are subscripts beside that capital P. So the capital P stands for permutation, and then the N and the R are purposely written below the P. They're written below ground level. That's just the notation. They are subscripts. For now, just kind of keep in the back of your mind, we'll talk about this more on the next slide, but for permutations, the order does matter. So when order matters, that's how I know I'm using the NPR button as opposed to the NCR button on my graphing calculator. So when order does not matter, that's when you use the combination button or the NCR. So the combination formula says the number of possible combinations if R items are selected from N items is, and again, here's the official formula, but it is programmed and ready to go in your graphing calculator. So to save us time, I'm just going to use the button in the graphing calculator. Just like with the permutation formula, N and R are subscripts when we write it out. So before we see an actual word problem example, let's just notice where these buttons are located in the graphing calculator. And again, please note that it matters if you use NPR or NCR because you're going to get a totally different answer. So example 5 says to find the following. So A, 8, permutation 6. Notice that the bigger number will always come first before the P. The smaller number will always go on the end. If you forget, you're going to get either an error message or 0 in the calculator. So it always goes big to small with both the permutation and the combination buttons. All right, so 8 permutation 6. 3 steps to get this into the graphing calculator. Step 1, we type in the first number. It was an 8. Step 2, we hit our favorite button for this chapter, which is the math button. Third one down on the left side. And just like with factorial, we got to go over to the PRB for probability submenu. I'm going to hit my left arrow key to get there quicker. NPR for permutation is number 2. Number 2. So I hit 2. It brings it onto the main screen. Step 3, I type in the smaller number, which was 6, and then enter for equals. Bam, there's the final answer. It's 20,160. So I'm going to jot that down. We said 20,160. B now wants 8 combination 6, or sometimes people will say choose. 8 choose 6 means the same thing as combination. So let's see how we would type that into the graphing calculator. Now let's type in 8 combination 6 or 8 choose 6. So I type in the 8 first. I hit the good old math button. Go over to PRB. Combination NCR is option number 3. So I choose the 3, type in the smaller number at the end, 6. I hit enter. See how it's a totally different answer than permutation? So 8 choose 6 would be just 28 for the final answer. So jotting that down, equals 28. So as you can see, it's much quicker to just use the graphing calculator. Feel free to use the app on your phone for the homework and quizzes anyway. And then you can check out a graphing calculator come test time from any mathematics tutoring center or library at Valencia College. For the rest of this video, we're going to discuss when to use the permutation or NPR button versus when it's a combination and we need to use the NCR button in the graphing calculator. So looking at example 6, Al, Bob, and Carrie have their names placed in a hat. 2 names are randomly selected. Determine whether the situation presents a permutation or combination problem. Before I read any further, please notice that even though there are 3 total names going into this hat, Al, Bob, and Carrie, we're only selecting 2 out of the 3 people. So whenever you're not selecting and counting out everyone or all the items, you're only selecting, counting out some of the items or some of the people's names, that's how you know it's either going to be an NPR or an NCR button question. So that's what makes it different from the examples we were doing earlier in this video, is that we are only counting out 2 out of the 3 total names. We're not counting out and rearranging all the names in a line or picking out all the names from the hat. So keeping that in mind, now looking at part A, how many different arrangements are possible if the first name drawn will be president of the math club and the second name drawn will be secretary? So to figure out if it's an NPR or NCR question, we need to identify if order matters. Whenever it's a competition, like they're competing for different titles, like president versus secretary in this example, or it's a race, or whenever there's a totally different arrangement when you pick the same exact names, those are all examples of when order matters. And when order matters, that means that this is a permutation question, so we need to use the NPR button within the graphing calculator. So let me just try to better explain why order matters. In other words, when I say order matters, in the context of this question, the order I select the names from the hat creates a totally different arrangement. It creates a totally different scenario. So let me just write it all out so we can see it a little bit better. I'm going to abbreviate Al's name with an A. I'm going to abbreviate Bob's name with a B. And of course, I'm going to abbreviate Carrie's name with a C. So I'm just going to list all the scenarios that could occur. So remember, the first name we draw is president. I'll put pres to abbreviate president. And the second name we draw is secretary. So the first scenario is we could draw Al's name first and Bob's name second from the 2 names we draw from the hat. In that scenario, Al would be president, whereas Bob is just secretary. However, here is why order matters. If I draw the same exact pair of names, but I draw Bob's name first and Al's name second, that's a totally different outcome, because now Bob is actually president, whereas Al is just secretary. So the order I draw the names matters. It creates a totally different outcome. That's what we mean by order matters. And there's definitely a few more scenarios that could occur here. Let me continue my list over here with my big old handwriting. We could also draw Bob, then Carrie's name. So Bob is president, Carrie's secretary. Or, again, we could draw the same exact pair of names, but if I draw Carrie's name first and Bob's name second, that's a different outcome, because now Carrie is president and Bob is secretary. Notice that I end up double counting every pair of names when order matters. I could also draw Al, then Carrie's names. So Al, president, Carrie, secretary. Or the 6th scenario, I could draw Carrie's name first, Al's name second. So Carrie, president, Al, secretary. And we're going to do a lot of examples in this video. But definitely with any kind of a competition, they're competing for different job titles. they are in a race, any type of a competition feel is going to be a permutation in NPR because the order matters. Totally different arrangement. So as we can see by listing every scenario, there are 6 total outcomes that we could have with drawing these 2 names for president and secretary. You don't have to list all the outcomes, fortunately, in the homework. I just wanted to list it out for you just so you could see what this button is actually doing when it spits out the answer of 6 in a second here. But we can see all the combinations permutations rather, that way. So I'm going to erase my little drawing here. So all you would have to do if this were my math lab homework question is you'd have to be able to identify, okay, order matters, it's a permutation, I got to use the NPR button. The bigger number always comes first. So there were 3 total people's names going into the hat, Al, Bob, Carrie. So 3. Permutation, the smaller number you always put in last. You're picking out 2 names. Remember 3, 2, those numbers are subscripts. So 3, permutation 2. And as we just saw doing it longhand by drawing the picture of all the scenarios, we should get an answer of 6. But let's just go ahead and type it into the graphing calculator anyway. So I type in the 3 first, math button, go over to PRB with the left arrow key. NPR is number 2, and it's permutation 2. Enter on the bottom right corner for equals, and bam, there's that answer of 6 that we were anticipating. So I'm going to go ahead and write 6 for the final answer. So again, if this were my homework question, because I know there are a lot of counting formulas. So we see the phrase how many, we know it's one of the counting formulas. Because I'm only going to count a few out of the total, I'm only counting out 2 names out of the 3. I'm only picking 2 names from the hat out of the 3 total names. I already have narrowed it down to either NPR or NCR. Because order matters, the order that I draw the names results in a different outcome, then we know for sure it is the NPR button. We type the bigger number in first, math button NPR, and then we type in the smaller number last, hit enter for equals. Same scenario, so we're going to put Al, Bob, and Carrie's names in the hat. We're still just picking out 2 names, but part B says how many different arrangements are possible if the 2 names drawn will attend the upcoming math conference together. So if they're both going to go to the same exact conference, who cares if I draw your name first or if I draw your name second? It's not going to result in a different outcome. So for that reason, the order I draw the names no longer matters. And when order does not matter, and you're picking out a few out of the whole to count out and rearrange, then it is a combination question, which means we're going to use the NCR button within the graphing calculator instead. And if you're not sure why order does not matter, let's draw the picture out again. So if I draw Al's name first, then Bob's name second, that results in the same exact outcome as if I had drawn Bob's name first and Al's name second. So I am no longer double counting these pairs of names like I did with A. So Al then Bob, or Bob then Al. Who cares the order we draw the names? You're both going to the same exact conference together, regardless of the order I draw the names. There is no advantage or disadvantage to being selected first. You could also think of it as. Another combination outcome is I could draw Bob then Carrie's name or Carrie then Bob's name. Either way, it's the same exact outcome. They're going to the same exact math conference together. And finally, I could draw Al and Carrie or Carrie and Al. So there are only 3 different arrangements. When it's a combination, order does not matter. So definitely makes a difference if you're going to use NPR button or NCR button. Totally different answers here. The only thing that's similar is you still put the bigger number in first. So there are still 3 total names, Al, Bob, Carrie. And we're going to do a combination or choose 2 of the names from the hat. Let's go ahead and put that into the graphing calculator. But we just saw, writing it out longhand, we should be getting 3 as the final answer if we punch it into the calculator correctly. So I put in the 3 first, then math button, go over to PRB, NCR for combination is number 3, and I'm choosing 2 names, enter for equals, and we get 3 as the final answer. So there are a lot of different scenarios that the My Math Lab is going to throw at you. But remember, once you've narrowed it down to it's either NPR or NCR, you always are asking yourself, does the order matter? Because if the order matters, then it's a permutation for NPR. If order does not matter, it's NCR. As we saw with this example, any type of a competition, competing for different offices, different jobs, different titles like president, secretary, is going to be NPR. You could think of it as there's an advantage or disadvantage to being selected first, but the order you draw the names results in a different outcome. Whereas if it's not a competition, they're just going to go to the same conference or the same workshop together. Order does not matter, so then it would be NCR instead. Unfortunately, it's not always a clear-cut case, so let's go ahead and look at several more examples of what the My Math Lab homework could potentially throw your way. Looking at example 7, how many ways can you select 6 free books from a list of 10 books? So I'm only counting out a few out of the total. I'm not rearranging all 10. I'm only counting out 6 out of the 10. So that already tells me it's got to be either NPR or NCR button, one or the other. So I've already narrowed it down to one of those 2 counting formulas. Now we need to ask ourselves, does order matter? If it helps, think of an actual example. So I'm counting out books. Let's say that I pick out the book Hunger Games. If I'm going to get all 6 books free anyway, does it really matter if I pick the Hunger Games book out first, second, or 6th? No, because I'm going to get it free no matter in what order I select the book. So this would be an example of where order does not matter. So any type of example where you're selecting out a few books, or you're selecting out a few DVDs or movies, anything like that, it's going to be a combination question where order does not matter. So that's the hardest part. Then you just throw it in the graphing calculator. We always go big to small number-wise. So I would type in the 10 first, and it's going to be 10 NCR button, and we're choosing 6 free books. And I'll let you type this in on your own. I'm sure you know where the buttons are by now, under the math button, PRB submenu. But when you try it on your own time, 10 combination 6, you should be getting 210 as the final answer. Looking at example 8. Example 8 says, in a race in which there are 50 runners and no ties, in how many ways can the first 3 finishers place? So we're not counting out and rearranging all 50 runners. We're only counting out 3 out of the 50. So that, yet again, tells us it's either going to be NPR or NCR button yet again. Because it's a race, order matters. It matters if you finish first, second, or third. You get a different trophy, you get a different award, and any kind of a competition we said would be NPR button. So order matters. So this one is going to be a permutation, which was the NPR button, bigger number first, which is clearly 50. Permutation, they're competing for the first 3 places, so 3. So 50, permutation 3. Your answer is going to be a large one. You should be getting 117,600 as the final answer here. In fact, let me go ahead and erase and move this answer over. So we did 50, permutation 3, and we get 117,600 after you type that into the graphing calculator. Looking at example 9, for a segment of a radio show, a DJ can play 7 songs. If there are 13 songs to select from, in how many ways can the program for this segment be arranged? So I purposely picked this example because I have had a lot of questions about this from the My Math Lab. There is a very, very similar question to this in your My Math Lab homework. And surprisingly, any type of lineup for entertainment, so whether it be like this scenario where it's a song, a musical lineup, or I've also seen in the homework about comedians telling different jokes. So I'll just write a joke lineup. Or if it's a lineup of TV shows that a certain station is going to play, or you're going to play on Netflix. So I'll just call this any type of an entertainment lineup, or bands are going to play at a concert, and you're going to pick out a handful of the bands to perform at this concert. So any type of entertainment lineup, surprisingly, order matters. Order matters. So if you play the love song first, they consider that a totally different arrangement, a totally different outcome as if you play it 7th. So order matters, which means it's going to be a permutation or NPR button question. Once we have that part done, that's the hardest part. Now we just got to get it in the calculator. Bigger number, we always type in first. It's 13. Permutation, that DJ is going to play 7 out of the 13 songs. So 13 permutation 7. It is a ginormous answer. If you put it into the calculator, you're going to get 8,648,640 different lineups for the final answer. And example 10, Baskin-Robbins offers 31 different flavors of ice cream. One of its items is a bowl consisting of 3 scoops of ice cream, each a different flavor. How many such bowls are possible? So a lot of these food examples, the order does not matter. Because who cares if you order the chocolate ice cream first, second, or third? You're going to be able to eat it. It's going to all go in the same bowl anyway. So food order does not matter, which means it's going to be a combination question, which is the NCR button. So the hardest part is done. We have our game plan. Type in, as usual, the bigger number first, which is 31. Combination, we're choosing 3 scoops. So you're going to do 31 NCR button 3. And you should get 4,495 in your graphing calculator after you type that in. For the last two examples, we're going to amp it up just a little bit more. Example 11, in December of 2011, the U.S. Senate consisted of 51 Democrats, 47 Republicans, and 2 independents. How many distinct 5-person committees can be formed if each committee must have 3 Democrats and 2 Republicans? So any of these committee examples, order does not matter, because if I pick a certain Democrat first, second, or third, he or she is going to be part of the same exact committee. Same with these 2 Republicans we're selecting. If we pick a certain Republican first or second, the order we draw the name does not matter. They're all going into the same committee regardless. So we know it's going to be a combination or an NCR button question. However, we're selecting a few out of several groups. So we're going to combine it with the fundamental counting principle from the previous video, which just really says to multiply. So we're going to be using a couple of NCR buttons, and we're going to multiply. Just think, keep like with like is our strategy here. Keep like with like. So, looking at, let's start with the Democrats. We got to go big to small. So there were 51 total Democrats, and we said it's NCR, so we're choosing combination 3. Let's put Dem to abbreviate Democrats, times, now again we're keeping like with like, we're keeping the Democrats together and we're keeping the Republicans together. So with the Republicans, there were 47 Republicans, and we're choosing our combination 2. And I'll put REP to abbreviate Republicans. In the homework, they might have you choosing the independents as some independents as well. So you would just times again the total number of independents, combination however many you're choosing to be on the committee. It's the same pattern at least to all of these. You're just multiplying several NCR buttons together. And now it's up to you how you want to get this into the graphing calculator. You can do each NCR separately and then times it. I like to do it as just one line. So let me show you what I mean by that. So we had 51 combinations, so math button, go over to PRB. NCR is option 3, and we were choosing 3. You have to hit the times symbol in between those NCRs. Now we had 47 Republicans, math, go over to PRB again, NCR, and they were choosing 2. Once you have the whole thing in the graphing calculator, hit enter. And that large number is our final answer, 22,511,825. So again, that was 22,511,825. And example 12, General Mills is testing 4 oat cereals, 5 wheat cereals, and 6 rice cereals. If it plans to market 3 of the oat cereals, 2 of the wheat cereals, and 2 of the rice cereals, how many different arrangements are possible? We said usually with food, when you're just selecting a few out of the whole, it's going to be a combination. If we think about it, that's going to be true here as well. If I choose the Rice Krispies first or second, who cares the order I choose it in? It's all going to be marketed together as part of the same campaign. So it's going to be NCR, and we'll multiply, and we're going to keep like with like, just like with example 11. So let's start with the oat cereals. There were 4 oat cereals, and we are choosing 3 to market. So for combination 3 times. Now the wheat cereals. There were 5 wheat cereals, and we are choosing 2 to market, times, finally, the rice cereals. There were 6 rice cereals, and we are choosing 2 to market. So you could put this all in as one line, try it, see what you get. If you've done it correctly, you should be getting 600 in the calculator as the final answer.